maybe 5 exams or something. I don't know, something like this. Okay. Anyways, you also have with you now. You should be Victor. You should be able to use the spine from the first book on this book. Yeah. What was I saying? Oh yeah. Now you should also have in front of you, which we need for today's lesson, why I needed to print it, is the formula book. So this is what you'll have for the final exam. You all have this? Yeah? So, yes, you had questions like, is this in the formula book? Well, now you can check yourself if it is or not. We would want for today, page 10, please. Okay, so last time we were looking at binomial distribution. Now, the only thing about last time's lesson, the lesson last time, speak English, is that I said the n was small. So what I meant by that is, for example, whatever. Suppose you had 10 people voting, so you had a vote of 10 votes, and the probability of a pass is 1/2. And suppose I want to calculate that the yes will win. Yes will win. So how many yeses do I need for it to win? At least 6. I could have 7, 8, 9, 10. So actually, if I want to calculate this, this would be 10C6 blah 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 plus 10C7, etc., etc., etc. And when that becomes quite big, this can take a long time. However, there actually is already calculated probabilities in these tables for situations like that. So this lesson is actually quite an easy lesson because we're learning how to use these tables for these types of problems. So we'll start with a simple example to show you how to use the tables.
We're never going to use the formula?
Oh no, we will use the formula, but some problems are large enough that they require the table book. And so let's take something like n is 5. And the way you use the table book, and we'll make need some air too? Yeah. It's like Saudi out there, isn't it? So hot. Let's say p equals 0.5. So I want the probability of 3 or fewer. Let's say these are coins. We flip a coin. So it's heads or tails. Heads or tails. So I want 3 or fewer heads. Okay, so previously, how did we have to do that? We have to do 5C0 possibility, 5C1, 5C2, and 5C3. But actually, the table book, you can use it for situations where you have an n, you have a p, and you want fewer or equal. So, for example, you know what? Actually, maybe I'll put the camera on so you can see. Screen cast. If it still works. No. Yes. Maybe. I can, there we go. Don't be shocked. Right, now, okay. So do you see down the side you have the n?
Yeah.
So the first table is for n is 5,
Yeah.
and the second one is for n is 6, and so on. And up the top is the probabilities. So where is the probability 0.5? I can't see on my camera. Is it down the very last one, is it? Yeah. And then down the side then, these are how many you want or less. So for the example, the first one is 0 heads or less, which is just 0. The next one is 1 head or less, which is 1 or 0. The next one is 2 heads or less. And then the next one is what I want. 3 heads or less, which is 0.8125. Now what about if I said 4 heads or less? What would that be? And why do you think 5 heads or less is not there? It's 1. If you flip a coin 5 times, you will definitely get 5 heads or less. Can you get 6 heads? No. So they don't include the last row if they're all 1s. That's why it only goes to 4. You see? Okay, so let's practice one. Okay. So I'll write one down and you try and use the tables. So what's great about this lesson, very simple lesson, it's all just about reading the tables. Okay, so
do we have to add it or just the answer already?
No, just yeah, it's already added. This is the great thing. So the answer is 0.8125. 0.8125 is the answer here. Yep. Okay. So you try this one for me. So let me see. We'll go with good old eggs. And the probability that it's broken, we'll say, we'll make 0.05. And we'll make this, we'll make it half a dozen eggs. So we have n equals 6. So we have 6 eggs. And I want the probability that, let's see, we'll say 3 or fewer are broken. Okay, I want you to use the table book and then tell me the answer.
0.999.
Yeah, 0.9999. Okay, can I scroll down? So let's make one a little bit difficult where we have to turn it around, where we say more rather than less. So for example, we'll say the probability that a car is blue, we'll say 0.15. And let's say we have 30 cars. So I want the probability that 10 or more are blue. Okay, try this one. 30 I think is at the back. Anyone think they have an answer?
0.0087.
Yes, very good. 0.0087. Because 10 or more is the same as 1 minus the probability of not 10 or more. And of course, not 10 or more is 1 minus the probability of 9 or fewer. So if you look at your tables, 9 and 0.15 is 0.9903. Can you see it, Malik?
Yeah.
Yeah?
Yeah.
Okay, let's try another one. So, yep. Okay. Let's see. We'll say that. What will we have? Probability that a student will pass their exam is 0.75. And let's say, how many students have I got here actually in this class? 12, isn't it? Normally 12, isn't it? Yeah. We'll say there's 12 students. Okay, so I want the probability that 10, or maybe that's too much. I'm trying to imagine. 9 or more, that's a 9. 9 or more pass. Yes. Thank you, Albert. 9 or more pass. Okay, try this one now. Now, I know that it doesn't go to 0.75. This is why it's a little bit difficult. So you need to think of a way to fix that.
Is it 0?
Oh, I think it's much better than 0.
Because 0.05 is 1. Let's see, it's not like 9 or more.
Just 0.648.
Well, calculate now. I haven't looked at it yet. Let's calculate it. But that sounds believable. Right. So, yeah, let's have a look. Yeah. Yes. Have a look. We'll do it here. So 9 or more passing. I'm going to change that into statements about failing. So if I want 9 or more to pass, that's 3 or less to fail. That's 3 or less fail. And in this situation, I'm thinking about the fail as the success, as the probability. So I can look up 0.25, n is 3 and p is 0.25. So if I go, sorry, not n is 3, n is, x is 3, but n is still 12. Yeah, x is 3. So 12, 3, and 0.25. Yes, 0.6488. Good job, Leon. 6488. Okay. Yes. Well, it's 75% is the chance of passing, 25% is for failing. So you just rethink about the problem as a failing problem than a passing problem. Oh no, Albert only wants it in English because he doesn't like his maths in Chinese. It confuses him, right, Albert? Yeah. Great. Right. One more example. Okay, so let's say there are people voting, and we'll say the probability that you'll vote yes is 0.6, and let's say there are, I don't know, 30 people vote, and I want the probability of 14 yeses or what did I do last time? Did I do more or less? More, so I'll do less this time. 14 yeses or fewer. Wait, hang on. Did I do more last time?
Yeah.
Oh yeah, that's right. I confused myself. Right, try this one now. So I'm just missing Nina, Pony, and Marcelo. We know any story? No? Nina will email me? Okay, what about Pony? Interesting. Andy's also not in today. I'm sure that's just a coincidence. I'm thinking about it too much, I must be, right? Dude, I don't trust what you're saying. You think you have an answer, Albert? What did you get? That sounds very small. No? That sounds a bit more believable, but that sounds a bit big. This is sounding more believable. Right, let's have a look here. So 14 yeses or fewer, that would be, for example, 0, 1, ... 14 yeses. But you can change that into no's. Yeah, like 0 yeses would be 30 no's, 29 no's, etc. all the way down to, what's this one, 16, isn't it? 16 no's. So in other words, it's the probability of 16 no's or more. Yeah? Yeah, sorry, no, 16. 30 vote. 14 yeses means 16 no's. Yeah. 16 no's or more. So that's the same as the 1 minus the probability of not 16 no's or more. Yeah, so not 16 or more means 15 or fewer. So that's 1 minus the probability of 15 or fewer no's. And what's the probability of a no, though? 0.9. Yeah, no, he's giving me the next part. N is 30 and X is 15. So, am I still 30 in total? Yeah. Yeah, so 30 in total. And we have a 0.4 and a 15. Oh, I don't know, John, where your answer, it seems believable, but now I'm having second thoughts. Wait.
3.
What? I was looking at the wrong table. Right, try it again. Point for 15. 0.9029. Okay, not 0.8 anyways. So what's that? About 0.1, isn't it?
0.0971.
Okay, so nearly 10%. Not quite 10%. Nobody got it. At least I didn't hear this one. So this is the most difficult type I can imagine using the tables. Why am I saying it's the most difficult? Well, because you have to do a few things. Firstly, you have to flip the yes to the no. Why do we have to do that? Well, we actually have to do that because the probability went past 0.5, so we have to look at it from the other perspective. And also, I had to do a 1 minus here. Why? Yeah, because it was or more, and our tables are for fewer, or less. So you can see actually there is no calculations in this lesson. It is just about using the tables. Yeah. So it's actually a good question for the exam, because this is the most difficult question I can imagine using the tables. And you can see once you practice, it's not too difficult. So I don't actually think it will take you too long to do these. There's 12 questions. It'll probably only take you 6 minutes, 30 seconds a question. Less? More? Some people might take less, John Way. Yeah. Oh, perfect. 6 minutes. So try this until 3 o'clock, and then we'll have a look at the next lesson then. You are on page 46, Albert. Thank you. Yes?
So you know when you minus one minus the probability?
Yeah.
That's because there's or say 15 or more.
Yeah. Yeah. And the table book is for or less.
Or less.
Yeah. Oh, by the way, just before you start, there's this grammar thing which I don't care about, but I'll tell you anyways. You know there's a difference between fewer and less. So when do you use which one? Oh, maybe you don't know. Oh wait, no, nobody knows this. There's a difference between fewer and less. Thank you, Malik. So which is which? Yeah, fewer is when it's countable, and less is when it's not countable. So you could have like 3 cars or fewer. But here you would have like, I don't know, less rice, less hair. Now I don't care about that, and most people speaking English don't care about that. So if you say fewer or less, I don't really care. But your English teacher might, okay?